Here's our objective then. I can add and subtract with signed fractions and mixed numbers. Last time it was multiplication and division. Now we have addition and subtraction. Now remember, the rules that apply for multiplication and division are not the same for addition and subtraction. Now the process is pretty much the same, but so in the process, I mean, first thing we're going to do is hopefully we can determine if an answer is positive or negative. After we know that it's positive or negative, then we can perform the operation. But with multiplication and division, like we saw with the starter problem, you can simplify numbers in the different fractions or even in the same fraction. With addition and subtraction, we have to force the denominators to be the same before we can operate, and that's the main thing. So we're gonna make some of the fractions. Well, maybe we'll enlarge or scale some of the fractions up so that the numbers are bigger. But we need the denominators to match before we can start adding or subtracting. So adding and subtracting fractions, you see it's the same idea here, as long as the denominators are the same. So that's what this is showing, the letter B, but it doesn't matter if it's B or even, it could be even another letter. We just need that to match. So as long as these are matching, we're in good shape. And the same is true for subtraction as well. So to go back from what we learned in the first lesson in this module, but in previous modules as well, the denominator tells us how big the pieces are, okay? Once the pieces are the same size, which is what both of these are saying, then you can add however many pieces there are, which is the numerator, or you can subtract them, the numerators as well. Now this step, I'm going to be showing this step, but I'll tell you this, most students don't usually show this step in their work, and it's okay if you don't. If you do, that's okay too, but I'm going to be showing this step just so we don't get that missing part, and plus it'll help me to make less mistakes, which it doesn't always work, but it usually does. The last thing here with the common denominators is you don't need the lowest common denominator. It doesn't have to be the lowest. So the method that I use generally does not use the lowest common denominator for most problems, unless I see that maybe the two numbers are, one of the numbers is a multiple of the other, right? So for example, if I saw one of the denominators is 2 and the other is 8, I wouldn't change this fraction. The look of this fraction, I would change this one into a denominator of 8 because I know 8 is a multiple of 2. Or, you know, if we had a denominator of 3 and then the other one was 12, okay, again, I know I can multiply 3 by 4. So multiply the numerator by 4 as well. And then I have matching denominators. That's the main thing. But if I get really funky stuff, like, I don't know, 3 and 7, okay, I can't magically make 3 into a 7 or a 7 into a 3. So in this case, I just multiply them by each other. That's correct. And then that will force the denominators to be the same or common. Now again, is that going to make them the lowest common denominator? No, it is not. And I don't care if it is, because I feel comfortable simplifying in the end so that if it's not lowest, I don't have to worry about it. So the thing with lowest common denominators, sometimes you'll use them in these problems, and then you still need to simplify in the end, which is another reason why I don't want to take the time myself to look necessarily for the lowest common denominator, but if you want to, that's fine. Well, I actually wasn't expecting, I know I made these slides, but I wasn't expecting the x's to be in the denominator right off the bat. Now the good news here, just like we were talking about on that last slide, is we have letter denominators, okay? But it's the same letter, right? You got the x's, and that's good news because they match. They're already common denominators, so I don't have to worry about forcing them to be the same. They're already the same. So again, like I said, I'm going to show this step, although most students don't show this step. The sizes of the pieces are in x size pieces. That's our denominator. Then all we got to do with the rest of the stuff, including the negative and the minus sign, is operate in the numerator. So we had a negative 13, and then we got a minus of 5. Boom. So my denominators match. Thank goodness. It saves me some time. meaning I don't have to worry about forcing those x's to match. Now I'm going to operate with that negative 13 minus 5. So I still have an x size piece in my denominator. I just need to know what that numerator is. So we're going to take negative 13 minus 5. So if you have something that's negative and the minus is going to make it more negative. So yeah, the minus there is going to make it more negative. And again, the reason I'm doing this is just to determine the sign of my answer. So if it makes it more negative, that means the sign of my answer will be a negative. Okay? Okay, well, the next thing we got to do, now that we know that the answer is a negative, is determine how negative it is. Well, if we wanted to determine that, we would take the negative 13, and since the 5 makes it more negative, more means add, we're going to add those 5. So 3 plus 5 in the ones place value is 8. Drop the 1, that would be 18 negatives. Now, I've included the negative already in the answer. Let's see if I can do that better. That's a little better. Negative 18 x's. I don't know. If you wanted to write it like this, you could. You can write it as negative 18 over x. It's the same thing. But it's not going to matter. You're going to get the same credit either way. Negative 5/9 minus negative 14/15. Just try this one out. Take a minute, try it out, then we'll go over it. Okay, so we need common denominators, right? And we got 9 and 15. Now, again, if you want to take the time and think, well, is 15 a multiple of 9? You want to usually look at the big one compared to the small one, see if it is a multiple of it. But 15 is not a multiple of 9. Again, you're looking at the big one because you would multiply the other one by some value to scale it up. But this one, it's not going to work. So I'm going to use not the lowest common denominator. Now, if you want to do that, that's up to you. But I am not going to do it. I'm not going to use it. 45, of course, will work. But all right. So like I said, what I'm going to do is I'm going to take the first denominator, 9, and I'm going to multiply it into the second fraction. Now, in doing this, some students like to make this minus negative stuff into a big plus sign or change it into plus plus or keep change kind of stuff. Doesn't matter. I'm not going to do that, though, yet. I will, just not yet. So this is going to give me a new fraction. Well, it's not a new fraction. It's just going to give me a new looking fraction, but the value is going to be the same. In the numerator, we've got 14 times 9, so we got to stack and multiply that. 4 times 9 is 36, carry the 3. 9 times 1 is 9, plus adding 3, plus the 3 is 12. So we got 126 over, then we got 15 times 9. 5 times 9 is 45, carry the 4. 9 times 1 is 9, but adding 4 makes that 13. So the next up, I'm going to take the 15 denominator. I'm going to multiply that into the first fraction. So 9 times 15, I don't need to do that operation because we already did it. We already know that's 135. And again, this is just one way to force the denominators to match. It's not the lowest common denominator, but it is a common denominator. So I have matching 135s in my denominators. But now I've got to do 5 times 15 as well, so we'll multiply that over here. 15 times 5. 5 times 5 is 25, carry the 2. 5 times 1 is 5, but adding 2 makes that 7. 75, 1/35. And now we'll look at we got the minus, or negative, minus the negative. So now I've got negative 75 over 135 minus negative 126 over 135. These, what I have in purple and red, is exactly the same as what we started with. We just changed the way they look. That's it. And now that we have common denominators, I'm going to rewrite the fraction. So I'm going to show this here. The fraction has a common denominator size, piece size of 135 or 135ths. Now the 75 is not just a 75 here. It's a negative because of the negative sign out there in the front. And we had a minus sign, so minus. And then, again, it had a negative with the 126. Now, I'm going to show this as minus negative 126. I'm not putting the parentheses on because specifically I want to show this as plus. A minus a negative is a plus. Some students like to say keep change, where you keep this sign then you change the operation and change the next sign, which would be plus a positive. Now, if you want to do that, that's fine. Again, however you do it is up to you. This is the way that I like to show it. And now that we have this, we can show this in 135ths. So now we look at the operation here with addition. Negative 75 plus, you could say positive 126. I have more, I'm adding, but I have more positives than negatives, so I'm expecting a positive answer here. Now we take the big number, 126, and the small number, 75. Since they are opposites that were being added together, we're going to subtract those. So 6 minus 5 is 1. 2 minus 7, we're going to make that 12 minus 7 to make 51. So positive 51 over 135. So it's not simplified. Now we can look and see, well, why is it not simplified? You can't divide these by 2, which is usually the most common one that we see. I see a 5 in the ones, but this 51 is not divisible by 5. So what is it divisible by? It has to be 3. 5 plus 1 is 6. 1 plus 3 is 4. Plus 5 is 9. And 6 and 9 are both divisible by 3. So let's get into dividing these by 3. Now these are kind of large numbers, which is my fault for not using the lowest common denominator. But if I divide these by 3, I should get the simplified form of our fraction here. So we're going to do, let's start with 51 divided by 3. 3 goes into 5 once. 1 times 3 is 3. Subtract. You got 2 tens left over. Drop the 1. 3 goes into 21 7 times. Yep. So 7 times 3 is 21. Nothing remaining there. So in our numerator, we got 17. Now the denominator, 135 divided by 3. 3 won't go into 1, but it will go into 13 4 times. 4 times 3 is 12 minus, drop the 5. 3 goes into 15 5 times. 5 times 3 is 15. Nothing remaining there. So our quotient is 45. Now, even though that is simplified once, I just want to check one last time and see if it can be simplified. 45 is divisible by 3, 5, 9, 15. That sounds all. I think that's all. 17 is not divisible by any of those. So that must be fully simplified there. Now, again, I did that. I would recommend that you do it too, no matter if you think that your answer is fully simplified or not. Just double check, especially on an exam, because if you don't simplify all the way, then lots of points, right? Now, this 45ths, right? If you had used 45ths back here, you would not have needed to have simplified your final answer. But there's no guarantee that will always happen, so just be careful on those. So on this one, it starts with a minus a negative. Now again, whether you look at this as keep, change, change. So some students like to show like this. You keep the negative, you can change this minus to plus and this negative to positive. Or if you want to just make that a big plus sign, is up to you, okay? I like to just make it a big plus sign because then I don't get things confused, but it's up to you. Okay, our denominators do not match. Okay, so there's a couple different ways you can find the lowest common denominator. I'm imagining that finding a list, a multiples list, is going to be our best option on this one. But if you feel comfortable with factors, that would probably work as well. So I'm going to start with the 28. So it by itself is its own first multiple, but I'm going to add another 28 there. So that'd be 1656 plus another 28. It's going to give us a 1484. Now, I've got 56 and 84 as my second and third multiples of 28. I know that I need one of the multiples to end in 0 because we got a 20 right there. So at least there's that much. So let's keep going. We got plus another 28. It's going to be 12 and 9, 11. So again, that's not going to work. But plus another 28. There we go. 3, 4, 140. Now 140 should be a multiple of 20 as well. So I'm going to stop there. That's the fifth multiple of 28. So let's take that fraction. It's negative. I'm going to keep that there. But I'm going to take 28 and multiply it by 5, and then 27 by 5. I don't have to multiply 28 by 5 because I already know that it's 140 by the multiples list that I made. But the numerator, I'm going to go ahead and multiply that, though. So 27 times 5. And I know it's negative, but I don't care about the negative. 7 times 5 is 35. Carry the 3. 5 times 2 is 10, but plus 3 is 135. So 13, 5, 135. Negative 135 over 40. Now again, I made that a plus sign. I got rid of the minus negative right off the bat, but you could wait if you'd like to. But we've got to get to 140 from 20 as our multiple there. So I got 20, of course it's its own first multiple. Plus another 20 is going to make that 40. Second multiple, plus another 20 is 60. Plus another 20 is 80. We're getting there. Plus another 20 is 100. Plus another 20 is 120. And plus another 20 gets us to 140.
So that's 10 times?
Yeah, so let's see how many multiples that is. 1, 2, 3, 4, 5, 6, 7. That's the 7th multiple for that second fraction. Now again, I don't really need to do the multiplication there. I just know that I'm going to end up with 140, but I'm going to show the work. That would have been 20 times 7, so I've got to take 17 and multiply it by the same factor of 7. So let's do that. 17 times 7, that'd be 7 times 7 is 49. Carry the 4. 7 times 1 is 7, but add the 4 makes that 11. So 119 1/40ths. Let's continue then. So this is gonna, let's add this up, but we got 1/40ths size pieces. Now again, I got the 135, but it was negative because of the negative sign out there in the front. So negative 135, and then we're gonna add the 119. A little bit more space. We should be able to finish this off. Okay, so my fraction is gonna be in 1/40ths. That could be simplifiable in the end here, but let's check.
Oh, shouldn't the 1...
So I just want to figure out if my answer is positive or negative. So we're adding, we got opposite signs. We got a negative plus a positive, but there's more negatives than positives. So I will expect the answer to be a negative. So I'm going to apply it to the numerator, although you could just apply it to the fraction if you'd like. Then we take the big number, which in this case is 135, and the small number, which is 119. And in this case, we're going to subtract them because they're opposite signs. We'll make that 15 by borrowing from the 3. 15 minus 9 is 6. 2 minus 1 is 1. 1 minus 1 is 0. So I end up with 16, negative 16 over 140. The next thing I got to do, so this is, we use the lowest common denominator, the only one that I can think of, the lowest one. But it looks like it can still be simplified, right? So 16 and 140, I know they're divisible by 2, but let's take that a little bit further. And let's divide by 4 here. Now again, I know my numerator will be a negative, so I'm going to keep that negative there. And in addition to that, I know 16 divided by 4 is 4, so that's the easy one. But 140 divided by 4, that's the different one. So 140 divided by 4. 4 won't go into 1, but it will go into 14 3 times. 3 times 4 is 12. So 4 minus 2 is 2. 1 minus 1 is 0. So we'll drop this 0. 4 goes into 20 5 times, yep.
Doesn't 16 go into 8?
So this one, again, you can divide by 2 twice to get the same answer. But at this point, we look at our answer, negative 4 over 35. Neither of those are divisible by 2 or 5 or 7, or both of them are not. So as it turns out, that is, that's it. Now again, if you wanted to write it as negative 4/35 like this, that's fine too. Notice on this one, we did use the lowest common denominator, but it still required some simplification at the end. So just understand, if you use lowest common denominators like we did here, you still may need to simplify in the end. So always check. Always in the end, before you circle your answer or think that it's done, just check to make sure that it is fully simplified. All right, negative 5/8 plus negative 15 28. Give this one a shot, and we'll go over it. So on this one, you guys use 56. Let's do that. Now, do you have to use 56? No. But I think it's going to be most convenient on this one. So let's do that. Now, again, I would look first and be like, well, 28 obviously is not a multiple of 8, which I think you guys noticed as well, which is why we have to use another multiple of 28. And I don't want to go all the way up to 8 because it's pretty big. So we're going to use denominators of 56. Now, knowing that we're going to be using 56 means that we also need to know 28 is its own first multiple. If you add another 28 to that, you get 56. And 56 is a multiple of 8. Now, that comes with knowing your multiplication table. So if you're struggling with your multiplication tables, then this may take a long time. But you can still do it, but we still recommend getting those memorized as soon as possible. So we're going to make our denominators 56s in both cases. All right, then we'll perform the operations. We got add, and then this second fraction is negative in the first one as well. We'll keep those negatives there. But how do we get those to be 56? Well, the 8, we're going to multiply by 7, and the 5 multiplied by 7 as well. So 7 times 8 is 56, which we already have. 7 times 5 is going to be 35 for our new numerator.
28, you times that by 2.
Correct. 28 we did multiply by 2. That's already 56, but 15 times 2 is 30. Now, I apologize. Sometimes you'll see my zeros. They're written, they kind of looks like a 6 right there, but it's just because my handwriting sucks, so don't be deceived. That's a 30 right there. Well, the 56's denominators already match, so now that we have that, we are ready to combine the numerators. So we are dealing in 56ths here. And again, we got a 35 to start with, but don't forget that negative sign in the front that makes that 35 negative as well. We have an operation which is showing as addition, which is good. I like to keep the addition there. And then again, the 30 is a negative because of the negative sign in front of the
So we're just
30
adding more
56. So this is why I like to keep the addition sign, because then I know that we're adding with the same signs, which are negatives. This is going to make my answer more negative, so that's a better equal sign. 56ths still, but we are going to add the negatives, so that means my answer will be a negative. What that means then is you have 35 negatives.
Minus 30.
Yep, and then you got another 30 negatives. We're going to add those together because our answer should just be more negative. So in the ones place value, 5 plus 0 is 5. In the tens place value, 3 plus 3 is 6. Negative 65 56ths. Now again, we should check. 56 is divisible by 7 and 8. 65 is not divisible by either of those. 65 is divisible by 5, but 56 isn't. 65, that's about all I can think of. Let's see. Nope, not 9er. So we can't divide these both by the same value to simplify. So it looks like that's it as an improper fraction, right? Now, if you like the improper fraction, and I do, then that's good. If you like the mixed number, which I'm not going to do the long division on this, but you'd get negative 1 and also 9 56ths.
So that's just
And that would be the mixed number. Now, I'm not doing the work here specifically because it didn't say that it wanted the answer as a mixed number. So there's no reason to do this extra work because it's not really needed. But if you wanted to use the long division, you can. I think we're going to do some problems later on that will want us to change this into a mixed number, or we just will. This one's a little different. We got negative 4 over 2 plus something over 6 equals negative 4/3. What it wants us to do is find this value, this unknown, this question mark. If we went back to, what is it, module 4, that'd be like an x right there. Then you got to use principles of equality to solve for x, which we will do here eventually. Let's see. So I don't know how many people notice this, but we got 4 over 2 right there. My first inclination is to change that into 4 divided by 2, which is 2. Now, doing that, though, isn't going to help us because we got sixths right there. And what we really want to do here is to get common denominators because we are adding 2 fractions, right? And as it turns out, 6 is a multiple of 2, so that's good news because, let's make this bigger, what I can do is take the 2 and simply multiply it by 3. So I'll multiply the 4 by 3 as well, and that will give me a common denominator of sixths. So I still got the negative sign, but 3 times 4 in the numerator is 12. So I've got that negative 12 sixths, which I've got this plus question mark over sixths equals negative 4 thirds. Now what would be even better right here is if this was in sixths as well, because if I take sixths and add other sixths, then I expect my answer to be in sixths as well. So since this answer is not in sixths, I can force it to be in sixths. Now again, I'm not changing its overall value. All I'm doing is changing the sizes of the pieces. And I can do that by taking, so let me get rid of that garbage. So that means I would take the 3 and multiply it by 2 to get sixths. Of course, this fraction is negative as well. But 4 times 2 is 8. Boom. Okay, so notice on this one, we're completely dealing with sixths altogether. Now, the good news about that is since all the sizes of the pieces are the same, we get to ignore the sizes of the pieces, which means we no longer need any denominators. Now, that may sound a little funky. We don't need the denominators. That's correct. Since all the operations occur with the numerators, we don't need the denominators anymore now that they are the same size pieces. Now, if they weren't the same size pieces, we couldn't do that. But they are the same, which means that I'm going to make that 12 negative. We got negative 12 of the sixths plus question mark of the sixths, and that's going to equal negative 8 of the sixths. This is an equation right here. But notice I know that I'm dealing in sixths, so I don't need the sizes of the pieces. I'm only dealing with how many there are. So I've got negative 12 plus something equals negative 8. And some of you may be able to do that in your head, but I'm going to show this with old principles of equality from last unit. So right here, whatever I do to one side of the equal sign, I got to do to the other one. What I'd really like is to know just what the question mark equals, not negative 12 plus the question mark. So the negative 12 is stopping me from doing that, so I'm going to zero it out by adding 12. If I do it to one side, I must do it to the other side. And that will zero that out. Negative 12 plus 12 is 0, allowing me to drop that question mark, which I've already done. The equal sign has come down, but now I've got the operation of negative 8 plus 12. That's a negative plus a positive, so I expect my answer to be positive because there's more positives than negatives. And then I would do the big number 12 minus the small number 8, which is 4. Now the question mark itself is 4, meaning if you were to go back here and replace that question mark with 4, if you were to replace that question mark with 4, the entire statement, especially the equal sign, would have been a true statement by replacing that question mark with 4. Of course, the process essentially would have been the same. So, in fact, let's take a look at that. So we had negative 4 twelfths. We changed it into negative 12 sixths. I'm going to keep that change, but then we added sixths. But we're saying that its question mark over 6 is now 4 sixths. This should equal the original negative 4 thirds, which we now know is negative 8 sixths, which we've already done the math there. That was now negative 8 sixths. Okay, well, this is in sixths, so negative 12 plus 4. Does that actually, so I got a question mark, does that actually equal negative 8 sixths? Yeah, negative 12 plus 4, we did that. That's negative 8 sixths equals negative 8 sixths. That's true. Last time I checked. And so, we now know that we have found the solution. Mixed numbers, negative 3 1/3 plus negative 4 1/6. Try this one out, see how you do. Now, just so you understand, there is another way to do this. I don't recommend going that way until you have a little bit more experience. And now, if you feel comfortable doing it, because I've seen students doing this in the past, and they're like, I get it, and I can do it this way. What they do is they combine the whole values, and then they only operate with the fractional parts. And then if they need to carry or borrow, that's where sometimes the problems happen and the errors happen. So I don't show it that way, but you can do it that way, okay? Again, if you feel comfortable enough to do it, that's up to you. But for me, I'm going to change these into improper fractions. So my first fraction, of course, it's a denominator of 3, so I'll keep the thirds, and I know it's going to be a negative. Okay, well, how negative is our numerator? Well, that'd be 3 times 3 there to start with. 3 times 3 is old 9er. And then we're going to add the 1 numerator, so 9 plus 1 is to make that negative 10 thirds. That's not a 6. And yes, my handwriting is not the greatest. And we'll keep this in parentheses. How about that? So negative, again, this next one is going to be, we'll keep a negative in sixth. So what's our numerator? So 4 times 6 is 24. Then add that numerator, so plus 1 is 25. So changing these into improper fractions, we have negative 10 thirds plus negative 25 sixths. The good news for us is that 6 is a multiple of 3. So I'm going to keep our denominators as sixths, meaning the second fraction here. We're just going to keep that the way it is. For the negative 10 thirds, I'm going to change that into sixths by taking the 3 and multiplying it by 2, so 10 by 2 as well. So it's still going to be negative by the sixths, and 10 times 2 is 20. So our denominators match, and that's good news, because that means that we can combine now the two fractions with addition. I'm gonna do this downwards, which is not what I've been doing in the last several problems. Again, however you show your work is up to you. So I got sixths. How many sixths? Well, we got negative 20 of the sixths, and then we're going to add another negative 25 of the sixths.
Again, we're just making bigger negatives.
Correct. Yep, so we will remain in sixths, however many sixths there are, but we must combine those negatives. So yeah, it's a negative plus another negative, so I will expect this answer to be more negative, more meaning we're going to take the 20 negatives, and then the 25 negatives, we're going to add those to them. So that this will tell us how negative it's going to be. 0 plus 5 in the ones is 5. 2 plus 2 in the tens is 4. So I got negative 45 sixths. Now that's pretty good, and that's a lot of work right there. However, this is not complete, because the last thing we should do is always check to make sure that the fraction that we have is not simplifiable. This one is simplifiable because 4 plus 5 is 9, and 6 is divisible by 3. 45 is not divisible by 2, though. So that means we need to take both of these and divide them by 3.
Well, I sort
And on the way that I have it, okay, so 6 divided by 3 is 2. I got negative 45, so I'm expecting this answer to be a negative. But I've got to do 45 divided by 3. 3 goes into 4 once. 1 times 3 is 3. We used up 3 of the 4 tens, so we got 1 left over. Drop the 5, 3 goes into 15 5 times. So that would have a remainder of 0. So it's negative 15 halves, or if you wanted the mixed number, you'd get negative 7 1/2. Now I'll show how we get that, right? So that's just, you take the 15 and divide it by 2. 2 goes into 1 0 times. 2 goes into 15 7 times. 7 times 2 is 14. You do get a remainder of 1. So the 7 quotient is the whole value. The 1 remainder is the numerator. We already had this in halves, and so we get negative 7 halves, or negative 15 halves. Okay, now with that, so let's go back here. So if you went back there and you did negative 45,
divide
in
by
fact,
6.
let's even not make that negative, right? Because we don't care about the negatives, right? So negative 45, let's divide this by 6. So 6 won't go into 4, but it will go into 45 7 times. 7 times 6 is 42. And when you subtract that, you get a remainder of 3. And then your mixed number would be negative 7 3/7 rather. Which is good. This is correct. It's just not fully simplified. So the 3/6, that's where it kind of causes problems there. You got to take the 3 and the 6, divide them by 3, and then you will get negative 7 1/2 as well.
Yep.
So however you do that, even if, so if you use long division there, it's important to know that you can simplify at this point. So always check your fractions, even for your mixed numbers in the end, if you get those. Always just check to make sure that that cannot be simplified. Because if it can, you need to. Now, we are adding two fractions. There is a k there. The k is a problem. It is a problem. However, we know we cannot add those two fractions together until the denominators are matching or common. So I'm going to force them to match. I'm going to take the first denominator, which is 7, and I'm going to multiply it into the second fraction. In fact, I'll kind of reverse where I put that 7 on purpose. So I'm going to do 7 times 3, but I'm going to do 7 times k as well. So that's going to give me a new fraction, a new looking fraction, although it has the same value. I have 7k's over 7 times 3 is 21. Now I'm using 21, of course, because I'm going to multiply the 3 denominator in the second fraction into the first fraction. So 7 times 3 there is going to give me 20/1. And then 6 times 3 is going to be 18, although they are negatives. We're adding these together. Okay, the denominators now match, which is great news because then I can add the numerators. So I've got 20/1. We're going to be adding the two numerators together. The first one, again, it's not just that it's 18. We have the negative sign in front, so it is going to be negative 18 of the 20/1. And then the other numerator was 7k. Now, in the last several problems, we did combine these together, but what we learned in the last module is that these two, the negative 18 and the 7k, are not like terms. Since they are not like terms, I cannot combine them, which means, and I think this is a good thing, we are done with this problem. Try to do that a little better. That's a little better. It's done. So a lot of students, they look at this and they're like, man, that's kind of weird. We shouldn't see answers that look like that. It almost looks like garbage. I mean, I can't really help how it looks, but it is done. That's just as far as we can go. I will add this in here. If let's say that we had something, I don't know, bigger than these. If you look at the 3 values that are here, like let's say that I didn't use 21. Maybe I used 40 seconds instead for some reason. Then you got to be careful because it is possible to have something that's a little bit more simplifiable. We shouldn't see something like that yet. But again, if you're not using what would be the lowest common denominator, you may need to do some simplifying after that. So for these types with the k or the x or whatever is in the numerator, I would recommend using the lowest common denominator for these, no matter how much time it takes, because again, if you don't use it, then you may have to do some more simplifying, which we don't want to necessarily do yet. Okay, so we have subtraction. Again, I don't really care if it's subtraction or addition. I just know that if I'm adding or subtracting, I definitely need common denominators. So I'm going to go back, not just to the last problem that we did, which we used the same method as we did on the second problem in this lesson with, what was it, like 15ths and, I don't know, 20, whatever it was. In any case, I'm going to take the first denominator, which is 3, and I'm going to multiply it into the denominator of the second fraction. Now, again, this is all in an effort to force the denominators to match. Because I am subtracting those two fractions, I need the denominators to match. And right now, when they match, I'm expecting them to be something like a 3c. Now, even though it's 3c, that's okay. You can have c's in the denominator. That's all right for now. Okay, but if I did that in the denominator for that second fraction, I've got to do it in the numerator as well. So I'm going to do 3 times 2 in the numerator, which is going to be 6 3/7, which does sound kind of weird. Okay, so we're going to take the second denominator c and multiply it into the denominator and numerator of the first fraction. So that gives me 3c. In the numerator, 1 times c. You can show it just as c, but I'm going to keep the 1 there because I like it. But you don't have to keep it there. So 3 times c is 3c, 3 times c is 3c. Matching denominators. That's great news because now that the denominators match, we can just deal with 3 3/7. I don't know what I'm saying anymore, but the first numerator is 1c, but it's not just 1c, it's negative, right? Because of the negative sign there. We said we're going to subtract, and then the second numerator is 6. Once again, we're dealing with addition and subtraction. Well, subtraction here. But these are not like terms again, which means we're done. That's it. That's as far as we can go on this one. Oh, well, I guess, I kind of take that back, although it's not really taking it back. Some people like to see that 1 as a phantom 1. And if you want to show it there, that's fine, like I did. I kind of like to see it. But if you don't show it, it would make some math people really happy. But it doesn't matter to me because it's still the same answer. That's all we got. So I can add and subtract with signed fractions, mixed numbers. The processes are pretty much going to be the same. Again, with the mixed numbers, I would highly recommend changing those into improper fractions and then operating. But again, some students are able to work with those directly, and that's up to you. Just be careful if you're going to work with those directly, that's all.